Let's have a quick look at hematopoiesis. Hematopoiesis, the definition, is the formation of cellular components of blood, including red blood cells, white blood cells, and platelets. So we've already talked about blood being like a person and that analogy. Here are the three big brothers that are in the blood family. You've got the red blood cells, you've got the white blood cells, and platelets. Where do they come from? Where did this family start? Okay, so our blood family, actually, like the histogenesis, it all starts in the red bone marrow. As an adult, hematopoiesis occurs in the red bone marrow, and these cells, the cells that give birth to this family, that produce this family, these are known as hematopoietic cells. These hematopoietic cells are derived from the mesenchyme, which forms the mesoderm. So, hematopoietic cells are our main players here. They produce the three big brothers, and they are derived from mesenchyme. Now, hematopoietic cells and cellular components are from, specifically, they're from something called pluripotent or multipotent hematopoietic stem cells. These pluripotent hematopoietic stem cells are what produce everything else. Now, there are two specific lineages that we need to know for these big brothers. Now, we know that red blood cells' office name is erythrocytes, white blood cells' office name is leukocytes, and platelets' office name is thrombocytes. Now, there is something called a myeloid lineage and a lymphoid lineage. Lymphoid lineage is for only the production of lymphocyte cells. Myeloid lineage is for only the production of, wait for it, erythrocytes. Okay, wait. For erythrocytes. So, myeloid lineage is for the production of everything else. So, it's for the production of erythrocytes, thrombocytes, granulocytes, monocytes. Okay? So, multipotent or pluripotent hematopoietic stem cells, PHSC, give rise to something called hemocytoblast. Hemocytoblast gives rise to something called a common myeloid progenitor, sounds like a virus name, or a common lymphoid progenitor. Let's discuss the common myeloid progenitor and what it gives rise to. The common myeloid progenitor plays a key role in erythropoiesis, thrombopoiesis, granulopoiesis, and monocytopoiesis, whereas the common lymphoid progenitor only plays a role in lymphopoiesis. Okay, people. Now, those are the big guys. The process of hematopoiesis, or let's start with erythropoiesis specifically. So here is a diagram that I've drawn of everything that's happening. Here's the hematopoietic cell. Here's it giving the lineage for the lymphoid lineage, lym-lyn, or the myeloid lineage, myel-lyn. Now, the lymphoid lineage is common lymphoid progenitor. This is common myeloid progenitor. Common lymphoid progenitor, easy peasy, gives rise to the lymphoblasts. Blast things are the ones that are producing things. So this is lymphoblast, makes sense. Producing lymphocytes. Easy peasy, done and dusted, over. Now, this common myeloid progenitor gives rise to something called a myeloblast. This myeloblast can give rise to many, many things. There's three things here. It gives rise to Ben. Myeloblast is friends with Ben, and it's for friends with half of milia, so because lymphocytes are here, or was that leukocytes? Anyway, I think it's okay. Now, Ben is produced by myeloblast. Common myeloid progenitor can either go into a myeloblast, produce a band neutrophil, a band eosinophil, or a band basophil. Now, these are called band because these are the immature versions of the mature neutrophil, immature versions of the eosinophil, immature version of basophil. These, once they cross into the blood and cross into the epithelium, so when they go into the bloodstream, these can become mature neutrophils, eosinophils, or basophils. Neutrophils, just for reference, is part of the acute immune response. inflammation and infection. It's the first response, it's the first inflammation, and it's in the highest percentage. This is the highest percentage in the granulocytes, okay? Because remember, Ben was spotty. That's why we remembered that they're spotty, so they have granules, so they're granulocytes. Now, quickly, what is eosinophil? Eosinophil is for allergies, basophils are for allergies. Remember that basophils gives rise to mast cells, and mast cells produce histamine, heparin, and serotonin. Basophils are with allergic reactions, and these are to do with parasitic infection. Eosinophils is with allergic as well, but this is to do with sensitivity. Now, the common myeloid progenitor can also produce either a pro-monocyte, which then gives us a monocyte, or it can produce a mast cell precursor, which then gives us a mast cell. Easy peasy. And then common myeloid progenitor can also give us something called an erythroblast or a megakaryocyte. Now, those are two different pathways. Let's quickly discuss erythropoiesis, because you have to mention erythropoiesis. So erythropoiesis is after you've got the common myeloid progenitor, you've got the hemocytoblast. The hemocytoblast gives us the common myeloid progenitor, okay? It gives us the common myeloid progenitor. After that, what happens? Basically, let me tell you. Peanut butter, eat paper, eat Oreo, okay. Peanut, pro-erythroblast. Common myeloid progenitor, pro-erythroblast. Butter, basophilic erythroblast. Eat paper, polychromatic erythroblast. Orthochromatic erythroblast, mature erythrocyte. So you've got hemocytoblast, you've got common myeloid progenitor, you've got pro-erythroblast, you've got basophilic erythroblast, you've got polychromatic, and you've got orthochromatic. Then you also have a normoblast and a reticulocyte. Okay. Here, myeloid progenitors can give you myeloid blasts, which give you BN and blah blah. Lymphoid stem cells give you lymphoblasts, which give you lymphocyte. What about thrombocytopoiesis? This is platelets. You've got megakaryoblast, pro-megakaryocyte. So you've got megakaryoblast, you've got pro-megakaryocyte, then you've got megakaryocyte, then you've got thrombocyte. That is it. I think that shall be enough. Oh yeah, just for this essay, you also have to mention erythropoietin. So basically, you can mention fetal sac. You can mention the liver, spleen. You love a smart bunny. You can mention liver, spleen, yolk sac, liver, spleen, and bone marrow. Or you can mention erythrocyte differentiation, which is erythropoiesis. You can mention regulation of erythropoiesis. Regulation of erythropoiesis is done by erythropoiesis is a process which happens in the red bone marrow. Erythropoietin is what regulates erythropoiesis, and it's secreted by the kidneys. And this hormone, basically, erythropoietin is a hormone which is secreted by the kidneys, which I've drawn here. This hormone binds to the membrane receptors on cells that will become red blood cells. They do not bind to erythrocytes. They bind to past erythrocytes, the ones that will in the future become erythrocytes, okay? Overall, pluripotent stem cells can either give us be precursors of thrombocytes, they can be precursors of white blood cells,